And so in this video, we'll be talking about the properties of the real numbers. And when we say these mathematical properties, what we're really thinking of them as our rules of the game. And so the first one is the commutative property. Now we've got a commutative property for addition, which basically says that a plus b is going to be b plus a. Now, kind of in words, that's really saying that it doesn't really matter what order we do addition in. We can do 2 plus 3. That's the same thing as if we did 3 plus 2. Now we've got a commutative property for addition. We also have a commutative property for multiplication, which pretty much says the same thing. A times b is equal to b times a. 2 times 3 is going to give you 3 times 2. Then it doesn't really matter what order that we do that multiplication in. So that's the commutative property. Our second property is the associative property. Again, we've got two of those, one for addition, that says, now we're really kind of thinking of these as our order of operations as well. That parentheses are really telling you what to do first. And so we've got two additions going on here. So the left-hand side is saying if we have three things that we're adding together and we add a plus b first and then we add c, well, that's exactly the same answer that we would get as if we added b plus c first and then added a. And so the associative property tells us kind of again that it doesn't really matter what order we do the addition. If we're doing multiple additions, that we're going to get the same answer either way. The associative property of multiplication is going to say pretty much the same thing, in that if we have three things that we're multiplying together, again, if we multiply the first two and then multiply the third, or if we multiply the second and the third and then multiply that by the first, we're going to get the same answer either way. And so what these two properties together really tell us is that addition and multiplication has some very nice properties that go along with them. And those nice properties are ones that we're going to take advantage of later once we start doing our algebraic manipulations. And kind of another really popular property that people know about is the distributive property. Now the distributive property is saying that if we have, so on the left-hand side, if we add two things together and then we multiply that by another number a, well, that's the same thing as if we multiplied a times the first number, a times the second number, and then added those two together. Now, so the distributive property we're going to use it in lots of different ways. Kind of one place that it'll show up is when we start combining like terms, kind of putting our expressions together. That's one place that it will show up. And we can also kind of use it as a nice way of doing mental arithmetic. So let's see how that might work. So let's see how the distributive property can be used when we're doing multiplication. And so suppose that we are asked to multiply the number 7 times 26. Well, we can look at 26 and we can imagine breaking that up as 20 plus 6. And so we've got 7 times the sum of two different numbers. And so what the distributive property then tells us is that this is going to be exactly the same thing as if we did 7 times 20 and then 7 times 6. Now 7 times 20 is a little easier for us to do in our head. We know 7 times 2 is just going to be 14, and so 7 times 20 is just going to be 140. 7 times 6 gives us 42. So 140 and 42, we can add that together in our head to get a final answer of 182. And so with a little bit of practice kind of doing that, we could really use the distributive property to multiply multi-digit numbers in our head rather than relying on a calculator or kind of the traditional algorithm for doing that. So the distributive property can be pretty powerful. Kind of a more complicated example. Suppose we want to multiply a couple of two-digit numbers. So let's say that we want to multiply 37 times 45. Well, we can begin by kind of looking at the 45 as 40 plus 5. And so when we do that, the distributive property would then say, well, that's just going to be 37 times 40 and 37 times 5. Now, the 37 times 40 is, again, kind of something that might be a little big to do in our head, and just like the 37 and the 5 in the previous example. And so we can use the distributive property again. And we can see that 37 as 30 plus 7. And we can apply the distributive property one more time, or we can apply it here with the 40. We can apply it here with the 5. And so we get something that looks like 30 times 40 plus 7 times 40, 30 times 5 plus 7 times 5. Now, these are a little easier multiplications just to do in our head. 30 times 40, well, 3 times 4 is 12. Add on 2 zeros, so we get 1,200. Again, 7 times 4, we get 28, so 7 times 40, 280. 3 times 5 is 15, so 30 times 5, 150. And then 7 times 5 is 35. We can add those numbers kind of together in our head if we wanted to, and so we get a final answer of 1665. And again, that's kind of one of those things. It's a little harder, but with some practice, we are actually able to multiply those multi-digit numbers together in our head and not have to rely on a calculator. So two other properties that we have are the identity property, which the identity property really is just saying that 0 is something called the additive identity. And what that really means is just kind of a fancy way of saying that anything added on to 0 doesn't change it. And the identity property also says that 1 is the multiplicative identity. That just means that 1 times a is just going to be a, so multiplying by 1 doesn't change anything. Now the inverse property says that every number is going to have an additive inverse or an opposite. So here, if we have a plus a negative a, so we get the opposite by just putting a negative sign on the number. So a plus the negative a is going to put us back to 0. And negative a plus a is going to also put us back to 0. We also have an inverse property for multiplication, which says that if we've got any non-zero number, then any non-zero number, we can get the multiplicative inverse, where we can reverse multiplication just by taking the reciprocal of that number. So a times 1 over a is going to give us 1, and 1 over a times a is going to give us 1. So the identity and the inverse properties are there for us to be able to say that we can always reverse addition and that we can always reverse multiplication whenever we're multiplying by something that's not 0. And so our last two properties are kind of a little bit of a different nature. So the first one is the addition property of equality, which is really just basically saying that if we start off with two things that we know are equal, and then if we add the same thing onto both sides, then equality is maintained, equality is kept. So that if a is equal to b, then a plus c is going to be equal to b plus c. We also have a multiplication version of that, so the multiplication property of equality, which says that if we start off with two things that are equal, then if we multiply both sides by c, well, again, we maintain that equality. And so these two properties are a little bit different, and they're important for one really big reason. That these two statements are what we see in mathematics as if-then statements. Now, if-then statements are really used to chain together logical statements. And one thing that we do in mathematics is that we are dealing with truth and truth values. And so if we want to start with two things that are true, something that's true, as we do our manipulations, we want to maintain that truthful value. And so we put our statements together in these chains. If-then statements allow us to do that. We think of the if-then statements as being inferences, and we can chain them together by thinking of the if as the input value, the then as the output value, and we chain them together by taking the output value from one statement, making it the input value for the next statement, and so on and so on and so on, just like a car assembly line, for example. And so the addition property of equality and the multiplication property of equality are those if-then statements that we will use to really to solve our equations. That basically what we mean when we say that we are solving an equation is we are finding a condition on the variable or variables that make the equation a true statement. And so we are looking for these truth values. So there is such a thing as truth, and in mathematics we are using that whenever we are solving our equations. So let's see how we can use the addition property of equality and the multiplication property of equality in action. So suppose that we want to apply the addition property with 2 to an expression like x is equal to 3. Well, what that would look like is that we are kind of assuming that we're starting with these values. So kind of again, we've got x is equal to 3. And so what the next thing is that we will add 2 to both sides of those. And so when we do that, we can actually add those values together on the right-hand side. So 3 plus 2 is really going to give us a value of 5. And so the addition property of equality really gives us that a final answer of that x plus 2 is equal to 5. So if x is equal to 3, then x plus 2 is equal to 5. Now let's see if we can use the multiplication property to do something similar. So let's apply the multiplication property of equality with 3 to an expression that we start off with just y is equal to 4. So what would that look like? Well, again, we begin with our input statement, which is just y is equal to 4, and the multiplication property of equality then says that we multiply both sides by 3, so we get 3 times y and 3 times 4. So over here on the right, again, those are two numbers that we can multiply together. So 3 times 4 is going to give us 12. And so we have a final answer of 3y is equal to 12. So we'll use these a whole lot more once we start solving equations and combining like terms. But for now, this is just kind of an introduction to all of the rules of the game that we're going to use from now on in all of our algebraic games that we're going to be playing. So stay tuned for that and recognize these when they start coming up.